Good morning, good afternoon, good evening to all who are attending this session. This session is on reducing the blast radius in Terraform by splitting the code into various folders and using remote data sources to pull data from different folders. So basically, this helped me, okay, the split monolithic code into smaller folders, but this may not work for everyone. So this is just one method that can be used. There are also other methods where you can use data sources or modules to split the code into, logical parts that can help you write simpler code and easier code to understand. So this is just one of the methods that I found out or came across, and it helped me. So this is what this talk is about. I apologize for any audio issues in the video. I don't have a proper mic, so there is a lot of distortion. So in case that is there, I have also written an article about this. So you can probably read that, and if there are any questions, I'd be happy to answer. Yeah, about me, my name is Leon. I am a DevOps engineer at a startup called Signians. We are an AWS consulting startup. My pronouns are he, him, and my Twitter handle is mediocre DevOps on Twitter. I mostly work with AWS consulting and cost optimizations along with Terraform. Yeah, so about me, I was a system administrator for the past 3 years. System admin come tech support, and I used to work with clients via tickets and chats on their private servers. And 6 months ago, I joined a startup called Signings, where we help clients with AWS solutions. We architect for them solutions, and we build Terraform code for them, and we give it to them. I also love a lot of anime and TV shows. My favorite animes are like Jujutsu Kaisen or Demon Slayer and Horimiya. I also have watched a lot of TV shows. I sort of like a lot of TV shows. I'm also quite new to the DevOps world. I don't have much experience in all the areas, but I'm currently learning it. I also have a ton of anxiety and nervousness, so in case I stutter in the video, please don't mind that. That is just me forgetting stuff. Yeah, so what exactly is Terraform? Terraform is an infrastructure as code tool. That means it will help you write your infrastructure using code, and these there are something called as providers that are created by the public, and public as in people who work with open source, and also there are official providers that are also maintained by people, and they are also open source. But there are some providers which are custom made or something like that. Basically, infrastructure as code tool helps you to put your infrastructure in terms of code, and allows you to build on it in a much better way compared to ClickOps, wherein you're in the console and you're clicking a lot of windows. ClickOps is good when you're starting out, so you'll be able to know what you have to create and how you have to create it and what options are required. For example, I couldn't directly just start with Terraform without knowing the things about EC2 instances, like what all are instance types and what all sizes are there for EBS volumes or security groups. How are they actually in the console? So it's always a good thing to start out in the console, or if you're okay with the code, you can also start out with the code. There is no one size that fits all sort of way. It also helps streamline your infrastructure. People have Excel sheets that you can use to sort of put your infrastructure on a sort of a master sheet or something like that. So Terraform also helps you with that. When it's in a folder, you can just go to your favorite Git repository hosting, that is the GitHub, GitLab, or whichever one you prefer. And you can basically view the files, view the infrastructure that has been created. They also have there also you can just put readmes, and so get a you can tell people that so and so folder, or so and so file does so and so thing. So there are a lot of there's a lot of ways you can document Terraform either inside the code or by creating readmes. It also allows you to create infrastructure plans. What I mean by this is when you run Terraform plan, it gives you an output, which is a plan, and you can store that output as like a file or something like that, and you can run Terraform apply on it. So in the plan, you get to see all the details that are being shown by Terraform, things such as how to create, what will be created, sorry, and what will be deleted, or what are the options that Terraform knows about, and what will be in the state file after apply. So that is also a very good thing on of Terraform. You can see what is being created rather than having an abstraction layer that you don't know what all things are being created for you. It also allows you to create graphs. Terraform graph is something that you can use to get like a graph of all the resources that are created. So you can get all the dependencies of what resource depends on what, something like that. So what exactly is a blast radius? Blast radius, I would say, is something that comes in picture when you have a lot of resources and you do an accidental deletion. Even though Terraform does give you an option to approve it, there are chances that you may go ahead and type yes, and just it so happens that your entire infrastructure, due to it being into one folder, you don't have it anymore, and fired. So basically, this blast radius is also, when you have a security issue or you have a breach with one account key, this also can come in use there, wherein you can give different types of access by the access key IDs. So yeah, all the basic Terraform code always starts from this very familiar tree structure where we have a production folder, and in the production folder we create multiple files with things like ECS, CloudWatch, S3, variables, VPC, and we just keep these files in a single folder. This is good for starting out for small companies where where you have less than 10 resources or 20 resources. I'm talking about like all the resources, like not subnets, route tables, individual resources. I'm just talking about resources in general, like RDS, EC2, something like that. This structure is good. It helps deploy your code faster, and you have all your resources. You don't have to reference them from anywhere. You can just use them in the same file. You don't have to use much of locals, nothing as such, and you're good to go. But soon time passes, and you have a lot of resources piling up, and you have different folders. You have UAT, you have testing, you have staging, you have production, and these keep growing. And once your organization grows, you don't have much time to go back to your old code and refactor it. It takes a lot of effort to refactor Terraform code and code in general. And this goes on, and you have long refreshes where just one small change leads Terraform to refresh everything, all the states, all the resources, and yeah, this can get a bit time consuming, and it's not a good thing. For example, for me at least, I cannot wait for more than 5 seconds when something is happening, or when CI/CD pipelines are building. I need a different task to do, and this can take a lot of time. It keeps going, and you can get exhausted with it, because even one small error and you will have to do the Terraform plan again, the apply again. The simple thing that I am proposing is to split the folders based on the resources. For example, we have a non-production folder here. We have a network folder wherein we can define our resources such as our VPC, our subnets, private subnets. You can use a VPC module to do this very easily, and the VPC module will give you a lot of outputs. So these outputs can be accessed, by different folders using something called as a Terraform remote data source. If Terraform remote data source is not something that you wish to use, you can also use data sources, but data sources can get a bit too much because you would have to, define a data source for every little thing, such as subnets, private subnets, public subnets. Your tagging has to be, correct in order to get these done. So, in order to, get to this structure, there are only few things required. You'll require a Terraform remote data source. For example, I use the S3 bucket as a remote data source. I've used locals because the module output that we get, they can be quite long when we are writing it, in the code. It can cause a lot of line breaks, and it makes the code a bit lengthy and unreadable. So I prefer to use locals. I just create a file locals.tf for that folder itself, and I will shorten the name to a memorable name or a shorter name with proper meaning, and I use that in my code as locals. Terraform outputs. This is the most important part, I'd say. In order to get your code working correctly with another folder, you would have to basically be able to, correctly define the outputs that are required. You can also define these outputs as you go. When you find out a new output that is required, you can simply add it to an apply, and your changes are done quickly in another folder. As I mentioned, you can also use a data source. Data source can also help you with things like VPC IDs. When you are creating this backend the first time, I would suggest you can use a data source to create something like for a backend VPC ID or a bucket name, something like that. Whatever is required, you can use that. Terraform locals are, I've heard a lot of people say, like, do not use too many locals, which is right. It's also, something that nobody tries to use much during programming itself. But in this case, these locals are, to the folder. Okay? They are for a particular resource, and they are logically separated. So I don't see any, disadvantage in using locals here, and they are much more helpful because I just have them in a single file, and all the locals can be viewed by anybody, and it can be read and understood what is happening. Yeah, so after we create the backend, I usually create the backend first by using a local state. Okay, and then I do a Terraform init, then I migrate the state to the S3 bucket that I create. I know it is a bit of a manual step there, but that is what I have currently. So the Terraform file structure looks something like this. You have a non-production folder, you have a network folder where you create all your VPCs, you define your subnets, and you create private subnets, public subnets. So I use a VPC module. So the folder structure is such as the main.tf has got all the main resource related definitions, such as the VPC module, uh, where I give what I want, like a NAT gateway per AZ, or no NAT gateway per AZ because they're quite expensive. Uh, don't get me started on NAT gateways. I find them quite expensive in AWS, that is. And the output. So your, the VPC module comes with a lot of outputs. If you head over to their GitHub page and you just look at the VPC module, there will be an example with the outputs folder.
In the output just file, I simply copy it, okay, and I remove any unnecessary or unwanted outputs that I don't require. And I simply keep them, so I don't have to sit and modify or define the outputs. All that I need are mostly there in the default example. Next is the Terraform.tf. In this, I define the provider. I define, the remote data source basically, from where I will request data or I will pull data to this as a read-only resource. There are also two files called variables.tf and Terraform.tf. Terraform.tf bar is something that is like a file that you can provide in your folder, and Terraform will automatically read the variable values from it, provided it is defined in variables.tf. So Terraform.tf bar is a file that you do not have to check to your GitHub repository. So it will be a file that you use during runtime, so it can be stored somewhere elsewhere. So yeah, this is about the file. The definition. So, for example, in the Terraform.tf file or the provider.tf file, whichever you prefer, I start by defining my provider, the AWS provider, for example. Here. I define a backend that is a remote backend here. So, the key is basically where I store the Terraform.tf state. It is in a separate folder with Terraform.tf state as a file name. I also specify the bucket that was created as a backend. We set this encryption to true. This is my AWS profile that I have to keep specifying. And then I provide the region and the DynamoDB table and endpoint. The DynamoDB table and endpoint is for state log. For example, if you give a DynamoDB table and endpoint, nobody will be able to, do an apply when someone else's Terraform state is currently active. You can also separate the states. There is no issue as such, or the state log. So you don't overwrite anything accidentally, and it can cause corruption issues also. So that's it for the provider file, the Terraform.tf file. Next is the outputs. Okay, the networks. I have now defined my VPC module. I have defined my subnets, everything, my CIDR block, and now I just want to create a simple output. It's a very simple setup right now. I really want to start by giving private subnets out. So this is a very simple one that I have created. This just gives me output of the modules that are the VPC modules that are created. So then I can simply, keep this in the same folder as a networks folder. Then, for example, I have a ECS cluster. So I want to use the data source in that cluster. So what I can do is I want to use a network data store. So I just create a data source with a type of Terraform remote state, and I just use the network as an identifier. I specify my backend, the configuration, the key, the region, the profile, and so on. And this is the usual writing of the Terraform modules, the Terraform backend that I want to use, the new one. I have not shown the provider definition here because of the lack of space and the slide becoming too long. So this is how I define the locals. Okay. If I want to use any locals, I can just take this local, set it as a VPC ID, private subnet, public subnet, and this is in another module. I have made a mistake. The file name, and this is in another module basically, where I can directly just provide the full name. As you can see, it's quite long. So locals come very handy in this case, where I can just say local.vpc, local.private subnet. So this helps me, reduce the long name and improve readability. Yeah, so that is how I define it. In case this is not completely clear or a bit confusing, I have also written an article about it where I have gone in more depth. But the whole point is that you can define your outputs in one folder, and you can call them in another folder using the remote data source option that Terraform provides. Yeah, so these are the locals. And so, what are the advantages of this approach? If you ask me, it is basically separation of resources into logical, components. For example, I can have my backend in a separate folder. I can have my, network in a separate folder. I can have my ECS. Inside my ECS, I can have a folder for clusters. I can have a folder for services. I can have a folder for task definitions. So I can break down the code into many small pieces where in case I accidentally try to do an apply and I don't see, or it's a human error sort of thing. Sure, we can run it in pipelines these days, but most of the time, sometimes we do have to run it on a system. So it can also help with that. Accidental deletion can cause less harm because say you run it inside a folder which is a small subset of your resources. There is no such thing as we can prevent disaster completely, but some we can at least limit the harm that we go through or we face due to the disaster. So this can help with that. You can make changes much quicker and much efficiently. For example, if I had to update something, in my ECS service, I don't have to wait for the entire refresh of Terraform to go through. So it's not Terraform's fault also, like the long refresh. And we have defined too many resources, and so this can help. The code also becomes a bit self-documenting. I can, give a code and I can map out a structure. I can tell somebody else to read it because it's in folders. So I can tell, what folder. I can specify a README per folder where if you're viewing it on GitHub, it will directly show like this folder contains so and so things. Plus the folders names are resources. So it is much easier to understand what is happening in the code. And of course, this is not a de facto method. Many people have told me to use modules over this, which is right. I haven't completely gone into modules since I haven't worked for quite few weeks on Terraform. I have not got a chance to explore the modules. So I would also, try to use modules more. Maybe when I learn it, I can find a better approach than this or something that helps. So I would say this also has a lot of repeatable code, and also you have to do Terraform init on every folder that you create. So you have to define a backend, remote data source. A lot of repetitive code can be there. Variable files appears. You need to maintain it correctly. You need to make sure the environments, the folders in which they are all correct. You'll also have to maintain many variable files per folder or something like that. State files also have to be named correctly. In case you accidentally, put another state file's name because we tend to copy paste a lot. So that also can affect this thing where your state files you overwrite a state file. That also can be bad. Creating a new folder can get exhausting because we have to define a provider, we have to define the remote data source, locals, variables. So it takes a lot of time to just get to writing your actual code that you wanted. Luckily, I was able to automate this since we had a lot of repetition. Sorry, we had a lot of repetition on this. So I basically just wrote a bash script that created these templates taking names from the arguments. But it's not everyone's thing, and nobody wants to sit and write bash scripts to automate something that can be done much better using some other kind of method. So this worked for me for a project. Hence, I submitted this, and this is like my first talk. I haven't spoken anywhere else. I try to write on blog on my blog, but apart from that, nothing much. Yeah, so that's it for the day and for my talk. Uh, if you like to talk and you want to connect with me on Twitter, on LinkedIn, you can definitely on LinkedIn. I'm just Leon Nunes.
Yeah, that's it. Thank you for attending this talk. I would like to thank HashiCorp for letting me give this presentation. This entire presentation is also an article, and it can be read on bit.ly. dev.ly04arc. And my dev2 profile is dev.to mediocre DevOps. That's it. Thank you and have a nice day.